So this unit, guys, is bonding. Joseph, can you put that away? Thank you. Pay attention. Take this down. Our bonding objectives are the following. We're going to review Lewis dot structure, make molecular models from model kits, draw structural formulas and Lewis dot structures for simple compounds, and we're going to identify molecular geometry, which is the shape of a compound, and we're also going to figure out bond type and polarity. Lewis dot structure is something that we covered in the past. Now it's the column number of the main group elements. So these are the main group elements, or the A group in your periodic table. You gotta stop that. So the first column, the first main group is 1. They all have 1 valence electron. The group 2 has 2. Group 3 has 3A. I know it's 13 on here, but it's the A group, the main group, the first main column. Yes, Marcus?
Are there any elements with more than 4, 6, 8 dots?
Nope. Everything has maximum of 8. That's why they actually call it a complete octet.
Can you have a negative?
Nope. Well, electrons are negatively charged. But a negatively charged thing would have to have gained an electron. That's an ionic compound, which I'm gonna briefly go over again.
Protons.
Protons are not transferable because that's not a chemical reaction. That's what we call a nuclear reaction.
Makes sense.
Good question. Good questions. So moving forward, so here are the examples we did in class yesterday, and these are correct. So take a look at these. I think a couple of these were also from our warm-up. Bonding electrons. Electrons that are alone are unstable. So they're either going to transfer electrons, and that's what we call an ionic bond, and it's normally between a metal and a non-metal, or we share electrons, and that's what we call a covalent bond. Metals are on the left side of the periodic table. Non-metals are on the right, upper right corner. Notice that hydrogen is a non-metal. Hydrogen up here, not a metal. Okay? So don't get confused. That's the exception on the left side of the periodic table. Some periodic tables, you'll see hydrogen in 2 places, actually. So you'll see it up here and over here. Ionic compounds are formed between a positive ion, which is normally a metal, and a negative ion, which is a non-metal. And that's because non-metals want to take electrons. Metals want to give them up. Yes, Joseph? So, and they form in a ratio to cancel the charges. The opposite charges become the new subscript, and we use parentheses for multiple polyatomic ions. So, what we're going to do is we're going to go over that when we're reviewing to our final, and here's a little cartoon that you guys can take a look at. You guys can take a look at it later, and it's just the positive ions are attracted to the negative ions. Covalent bonding is what we're referring to in this lab. Non-metals like to take electrons. So if there's more than one non-metal, they don't want to give it up, so they end up sharing. And each unpaired electron needs a partner. It's almost like you can think of an unpaired electron as a hand reaching out for something else. That's what an unpaired, a single electron alone. So every unpaired electron with a non-metal, you make one bond with another non-metal. So nitrogen has one pair of non-bonding electrons, so that's already fine. That's a pair. So they don't need to grab anything. Now it's your unpaired electrons here that are alone. They're like a hand grabbing something. It's like a 3-handed monster is nitrogen. It has to grab onto 3 things. And actually, it can actually, in molecular nitrogen, which is in our atmosphere, is 2 nitrogen atoms, and each electron is bonded to with an other nitrogen with another electron, making a triple bond. It forms 3 bonds. Excuse me. So if we have NF3, we have nitrogen makes 3 bonds, and fluorine, which makes 1. So when you put that together, you have a pair of electrons shared between nitrogen and this fluorine, nitrogen and this fluorine, nitrogen and this fluorine. So that's what the covalent bond is, each shared pair of electrons. Okay? And how we draw that out is like this. Each bond is drawn as a single line. It represents 2 electrons being shared. What?
What kind of bonds are they?
A covalent. Co because they together. It's like if you co-inhabit, you live with somebody. Covalent means they share the valence. Yeah. And these over here, and these guys, and a central atom, which we're going to talk about in probably a few minutes, are these nitrogen. You should draw these here. So nitrogen always has two non-bonding electron pairs. Can we look up? Okay. So they're still there. They're just not bonding. So water. We think we did. We'll do this yesterday. So let's move on. Oh, did we do this?
Nope.
Okay. So in your notes right now, I want you guys to do this. So we'll take a quick go. So the Lewis dot structure for oxygen. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, and 6. Kind of looks like that. So hydrogen each looks like this. So hydrogen makes how many bonds?
1.
1. Oxygen makes how many bonds?
2.
2. No, it makes 2 bonds because these are our bonding electrons. And I'll write that down up here. So these are our bonding electrons. Bonding electrons. Okay, so it makes 2 bonds. So the Lewis dot structure, this right here, this hydrogen is like one hand. And this hydrogen is like one hand grabbing for something, and it can only grab onto another hand. So it's going to grab onto this oxygen right here. This hydrogen, same thing with the other oxygen. Oxygen bonding electron. So its oxygen still going to have 2 non-bonding electron pairs. Those are still there. Those are still present. But what we have is, Marcus, cut that out.
Dude.
And we have our hydrogen. Each of those hydrogens is going to bond to one of the bonding electrons. So you have your total number of electrons. You have your total number of electrons before and after. Joseph, can you have a seat, please? So this is the Lewis dot structure. So how many dots do we start off with?
3.
How many total? 1, 2, 3, 4, 5, 6. How many? 7. 8 total. How many do we end up with? 8. We are always going to have same number of total electrons. We're never going to have more. The structural formula for H2O is instead of 2 dots as a bond, we draw a line. So we have oxygen bonded to hydrogen. And each bond represents 2 electrons. And you still have your non-bonding electron pairs. Those are still there. They're just not bonding. And they'll be relevant later. All right? Moving on. You guys are going to turn the page to the second page right here. So we're doing the number of, first do the Lewis dot structure, and carbon has 4 valence electrons. All right, hydrogen has 1. Colin, cut it out.
4.
Oxygen has how many, Colin? How many is oxygen have? Look at the periodic table.
6.
We did this in class today, right? How many? Where's your periodic table?
6.
Put that away. 6. Write this down. Oxygen has 6. 1, 2, 3, 4, 5, 6. Nitrogen has 1, 2, 3, 4, 5. Cl has 7. 1, 2, 3, 4, 5, 6, 7. Sulfur's the same as oxygen. Now, because it's in the same family, anytime you have something in the same family in the periodic table, it'll look the same. Yeah. They're more like brothers. Because sometimes they act alike, and sometimes they act alike, but not always. So how many valence electrons does hydrogen have, Marcus?
What?
How many valence electrons does hydrogen have?
One.
One. How many valence electrons does oxygen have, Diamond? 6. How many valence electrons
Why
does
6?
nitrogen have?
Why 6?
Because there's 6. 1, 2, 3, 4, 5, 6.
I thought we were counting the ones that don't have partners.
Nope, that's bonding. That's bonding electrons. Key thing, guys, is key thing here is that the total is the number of valence electrons. That's all of them. Total valence electrons. A bonding electron is a type of valence electron. Okay? So we have 5 here, 7, 6, and 7. Number of bonds that you can make. Okay, how many bonds can carbon make? 4. How many bonds can hydrogen make? How many bonds can oxygen make? Nope. How many unpaired? 2. 1, 2 unpaired.
3.
Nitrogen can make 3.
1.
1,
2.
2,
1.
1. Okay? So in anything in the family here fits in. So anything on that same column is in the periodic table. So like silicon is this, and
I thought it was pronounced
silicon is
silicon.
germanium.
Are we recording right now?
Yes, we're recording right now.
Wait, I saw what?
Anything in the column under here. So like has the same formula. So like Li would be the same, Na would be the same. What about O? What's the same as O? Look in the periodic table.
What's SI?
Silicon.
Silicon?
S, Se,
Silicon?
etc. What's same as nitrogen? What's another one same as nitrogen? What's one similar to nitrogen?
Is
Nigel?
that 2 S's?
S and Se. What's the same as nitrogen? Same old Lewis dot formula. Kyle, what's one similar to nitrogen?
Nitrogen.
It's in the same family as
I
nitrogen.
would say phosphorus.
Phosphorus.
Arsenic.
Good. And how about what's in the same family as chlorine?
Well,
Water? H2O?
Nope.
chlorine.
Fluorine?
Chlorine.
Hydrogen?
Nope, not hydrogen.
Bromine.
Chlorine.
Bromine, iodine.
Bromine.
Sulfurs, oxygen, Se. It's in the same family. Chlorine, fluorine is Cl, Br, and I. Okay. In our model kits, one bond, every hole is going to be by a bond. So we are going to do this. Okay.
Here's a question.
Marcus.
I never turned the thing off first.
Okay.